Unleash the engine that powers modern enterprises, industrial data pipelines. Far from the ETL scripts of old, industrial data pipelines give businesses the data they need when they need it, how they need it, so they can make decisions and get the job done. Learn more in this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Kavanaugh here. Very excited to have a bunch of my old friends on the show today and a fascinating topic, industrial data pipelines. Doesn't that sound cool? Fueling the modern enterprise. That's what we're talking about today. We've got several wonderful guests. My good buddy Mike Ferguson from Intelligent Business Strategies is here, probably from London, I'm guessing. Sean Knapp is dialing in from California, I'm guessing, and Beinan Wang is also dialing in. Sean is from Ascend, and Beinan is from a company called Alluxio, all doing very interesting work in this space. And so what are we talking about? Data pipelines. Well, in the old days, we just used something called ETL, extract, transform, load. You would extract data out of your ERP, you would transform it into a schema that made sense for your data warehouse, and then you would load it in there and off to the races doing your analysis. Well, modern data pipelines are much more complicated and much more robust. And as we'll hear, at least from Sean Knapp of Ascend, dynamic data pipelines are really where the action is. And you want to use declarative technology as opposed to imperative or programming. Declarative is where you tell the application, hey, I want this to be the result. Go figure out how to do it. Imperative is where you say, do this, do that, et cetera. Give very explicit instructions. So these are two different paradigms. Obviously, declarative is a little more interesting. It probably takes a bit more processing, but it's also dynamic. It just comes up with ideas of its own volition, not really like AI. But it is an interesting space to kind of dive into. But what I think I want to talk about here is that the changing nature of data in the enterprise and data movements. And it was funny in the pre-show, Sean was joking about the postmodern data stack. So we hear these folks talk about the modern data stack, and what they're really talking about is these new sets of tools and technologies for managing data at scale. Most of that revolves around this conversation of Kubernetes, which is a container orchestration platform that Google created, which really, it's almost like a de facto operating system for the cloud. And Kubernetes is amazing stuff. It allows you to distribute compute, essentially. So instead of having big monolithic applications, you can have these different pieces and parts and little ephemeral system processes in containers spin up and spin down as needed. Very interesting stuff, but really changed the game in terms of how we design and deploy enterprise applications. Well, so that's the modern data stack. It's very interesting, but postmodernism, I had to look it up just to crack myself up here. A late 20th century styling concept in the arts, architecture, and criticism that represents a departure from modernism and has at its heart a general distrust of grand theories and ideologies, as well as a problematical relationship with any notion of art. I was like, well, that's actually pretty appropriate to what we're seeing today in the world of data. And maybe, Sean, since that was your idea, I'll throw it over to you to comment on. I think we are now at a sort of roll up our sleeves and get to work phase, whereas we've been all excited about big data and now AI and LLM, and everyone's like, yeah, this is great. But someone has to pay the piper and someone has to get the job done. And that's where we are right now. What do you think, Sean?
Yeah, I think that's very much the case. And I think it's a byproduct of these two factors. First major factor is just the timing and introduction of these really new transformational technologies. And we're following really an innovation cycle that is very similar to a hype cycle of mass exploration, fragmentation, and eventually now we're getting down to standardization and consolidation, where folks are finding the best practices and the most common patterns. That's against the macroeconomic backdrop too of heavy funding of new startups introducing really new technologies, followed by I think a pretty strong pullback from investments in the space, which is meaning fewer companies, more consolidation. And this is really impacting the innovation cycle against the point in time where enterprises and buyers are also looking for really, how do we get productive? We've made all these investments. There's this exciting new space. We're doing all these things around this modern data stack, but we've explored a ton. We've bought tons of tools. We've integrated tons of things, but we got to start to get to work and produce value out of this. And I think that's catalyzing not only a move to the postmodern data stack, but really on a rather accelerated timeline, just given the nuances and complexities of the current market.
Yeah. Let's talk real quick about these dynamic data pipelines, because this is something that Ascend focused on, and it's a very interesting approach to use declarative technology to say, look, system of record, I want you to develop this result, and here are the sources of information. Go figure that out. Can you explain how that works?
Yeah, we've seen over the course of time, most technological spaces move towards declarative models as they mature. We've seen this with front-end engineering, with React, with back-end engineering, with Terraform for infrastructure, Kubernetes for container orchestration. And the reason is, in declarative, you're defining the outcome, and you lean on an underlying system, usually what's called a control plane, which is sort of like a domain-specific context-aware scheduler that is orchestrating and driving the behaviors. And the reason why this is possible as spaces mature is we're finding more common patterns that can be properly identified with rules and constructs that we can better automate. The other thing why I think this is so necessary as spaces mature is we've greatly empowered. I'd say many CIOs would say they may have over-empowered their organizations. And so we gave all these new people all this amazing new technology, and we got this networked effect of data that also created a network effect of dependencies and debt. Right. And so we have all like these, the most magnificent, in many ways, house of cards that all these amazing people have built, but it's all dependent on each other and loosely connected by what are powerful but not well-aligned technologies. And when you move towards a declarative model, the core premise behind that is we can actually use intelligent and highly automated systems to fulfill the architecture and design that, whether it's for container orchestration in K8s or in our world for data pipelines, that the architect, the data engineer, the analytics engineer actually foresaw with that. And you lean more aggressively on the automation to fulfill all those contracts. I think that's why we're at this really cool stage of maturity in the market where complexity is going up. People are looking for simpler systems, greater leverage for their teams. And so it's really this perfect storm right now for investments in this more declarative approach.
Yeah, perfect storm. I think that's exactly right. And, it's kind of funny because I think a lot of this technology is showing up just in time. And I guess it's part and parcel to what we're seeing out there in the real world. But all of a sudden, we have absolutely gobsmacking amounts of data. We have so many different data sources, so many new ways of capturing and leveraging that data, so many new ways of analyzing that data. So it's really, I think, just almost like a potpourri of opportunities. So, but we've kind of gone through the honeymoon, and now it's time to get to work and feed the kids, right? Bring in Mike Ferguson from Intelligent Business Strategies, but he also is one of the architects behind Big Data London, which is now like the biggest show in our industry, certainly in all of Europe, which is pretty darn impressive. And Mike, I'm going to throw a bit of a curveball to you. When I hear especially Sean talking about these curves collapsing on one another and things getting serious for a lot of businesses out there at a very challenging time, I think one of the things we're going to see shake out of this is a much more lean and efficient approach to managing data. And I think a lot of the heavy lifting that we've done over the years with ETL and filling data warehouses and all these things, that's going to have to be toned down a little bit. But luckily, AI is very clever stuff, and we can find signal in new ways with less data, I believe at least, and solve some of these business challenges without doing so much heavy lifting. And then observability, which is a key part of this whole equation as well. I think with observability, we're going to start to see what hasn't been used, what hasn't been pulled into the business, what data isn't being analyzed that we're storing and processing and managing, because you got to cut all that nonsense out going forward. But Mike, what do you think?
I would agree to that. I think one of the things that I would also agree with Sean on is the days of playing around with lots of tools and having everyone go out and buy their own tools is really over. I think what a lot of organizations are now saying is, we really do need to rationalize in order to get stuff done quicker, because there's too many bridges out between tools. But I think what we've also seen over the last few years has been the adoption of machine learning and AI moving into data management software. And that would include things like catalogs to be able to automatically discover and recognize patterns in data, to classify data, to automatically map physical data names to common business-friendly business terms. And because software is able to automate that and generate most of the mappings, it then becomes increasingly easier to then go the next step, which is to start generating pipelines to do this, rather than expect people to build those all the time. And so for me, it's kind of second generation automation. We kind of saw the first generation maybe as much as 15 years back, where people keyed metadata into tools and it started generating stuff. But now we've got to the point where we're automatically able to create the metadata. And so we're then in a position, having got to that stage, to plug into that and then generate from there. So, but I also believe that we're moving towards what I would call component-based development of these pipelines, so that there are standardized components based, again, on what you're saying on observability and what Sean was saying. We learn about patterns to do things. If I need to perform a certain task that is very common in a pipeline, then why does everybody have to do it again, build it again? Can't there be a sort of corporate standard for doing that, whether it's masking data or whether it's address validation or whatever it happens to be? But I think as we build up more and more of those and get best practices coming in, and people incrementally build up more and more of these kind of common components, then other people coming behind them get to reuse them, and we get faster and faster and faster potentially at building these pipelines. And so ultimately, from my point of view, I think that the combination of metadata plus observability plus even recommendations building using AI and ML going into development processes, and something called reinforcement learning with human feedback, where either the recommendations are accepted or rejected, but either way they're recorded and then go back into retraining models to know what to recommend better next time. But ultimately, all of these things are accelerating the development of pipelines, and therefore allowing us to get greater and greater reuse and more automation to the point where we get progressively faster and faster. So despite the fact that the amount of data is spreading out, getting progressively worse, there's more and more of it. We're potentially moving towards an era where if we get it right and we start to rationalize and join up tools, then I think you can get progressively more productive.
Your host here, Eric Kavanagh, with an all-star cast. We've been hearing from Sean Knapp of Ascend and Mike Ferguson of Intelligent Business Strategies and Big Data London. Look it up, folks. Big Data London coming mid-September, I think 11th through the 13th or something like that. So check it out, folks. If you're in London, go check it out. If you're not, get on a plane. Go check it out. Next up, let's bring in Beinan Wang from a very cool company called Alluxio. And these folks were born, as I recall, correct me if I'm wrong, out of a use case trying to leverage the compute power of the cloud on all the data you have on-prem, especially in Hadoop. For those who remember the big elephant, it was going to solve all the world's problems with MapReduce. That didn't quite pan out. I don't think LLMs will solve all the world's problems either. You have to use these technologies in their own space. But Alluxio knows a lot about I/O. the input output for these computers and how they operate. So with that, Beinan Wang, tell us a bit about Alluxio and what you folks are doing to enable the use of data in this modern world.
Oh, yes, yes. I would like to continue about our pipeline discussion. As Mac mentioned, there used to be something like a first generation of pipeline. In that stage, somehow, something like the big internet companies, they have built their own data center. And it's more like a centralized pipeline. They will put everything together. They will put their data, their computer engine, like the MapReduce, like Presto, like Hive, whatever. They put this kind of all together in the same data center. Maybe we can call it the first generation, the ETL things, everything's there. But definitely, they have very good performance because they always fetch data from a local data center. Am I right? But the thing is, the scalability will be a big challenge because some companies they want a bigger computer power or something, but if they build their own data center, the space is quite limited. They have no space to buy more new machines to enhance their compute and their storage. And I think if we're talking about the AI training or the AI serving today, you can see another problem for your own data center because the GPU. The GPU is really difficult to get today. Am I right? So most companies, they cannot even buy maybe 100 GPU cards by their own to put them in their own data center. Even they have space. No, it's not possible. There is no GPU in the market. So they have to build their GPU compute, something like a model training, on some remote data center. Probably they run this kind of GPU from some cloud provider. But the thing is, their data probably is still in their own data center or maybe probably on another cloud provider. So the thing is, nowadays, I think maybe we're talking about the pipeline. Currently, they're more like a decentralized. They can be everywhere. Maybe you have 100 GPU card on Amazon, maybe the other 500 GPU card on the GCS, they're on GCP, right? So the thing is, in this case, we always fetching the data from remote. But the thing is, we have large scalability, but we have a lower I/O performance. Then the Alluxio kicks in. Right? We put something like a unified data access layer with a cache. Okay, so mostly you can just access your data on demand, and the Alluxio will help you to cache the data in your something like a local Alluxio cluster. And also we provide a unified interface. Then I think that all the cool things on the cool pipeline, like the dynamic pipeline from Sean, I mean, your engineers can focus on your logic. You don't have to think about, okay, in this time the data is from S3, next time the data is from GCS. You don't have such kind of concern. All the data are from unified interfaces from Alluxio, and also you don't need to really care about the location of the data. You just think about, okay, just local data. You can mount all your data into a local folder, just something like a local data. And as we mentioned, a lot of machine learning engineers, it's just Python engineers. They like to load or manipulate some data from a local folder rather than call some remote API like S3. So
yeah, right.
We can mount their data as a local folder. Then you can just use it directly. Yeah, I think what we are doing is we speed up the I/O, and we also provide the convenient to the end users. And also we provide something easy to maintain for the infra engineers, like Sean. If they want to build something on top of the storage, I think it will be much easier for them.
Yeah, that's very interesting. And as I recall, you did some clever innovation around namespaces, and that's a key to your innovation. Can you talk about that for a minute, what that means and why it's important?
Oh, yes, exactly. I think if I'm talking about that time like 15 years ago, maybe everything is from HDFS. So you can see the URI, or maybe you can see the key, the path for data. It always starts from something like HDFS, something. But the thing nowadays is if you do some training job, your data can be from everywhere, as I mentioned. So sometimes it's from S3, so you can see the path or your data URI. It's some start from S3, something. If it's from GCS, it's from GCS, something, right? So if you want to change your data provider from S3 to DCS, everything got changed. I think that's just something as Mike mentioned. If you want to build some metadata management, which means the path will be super important for them. If you change the path, from the S3 to DCS, it will be a disaster. We need some tools or some effort to do the migration. But by using Alluxio, we have a unified namespace. We can simply think it's more like a mapping. So every data path is start from Alluxio. But the under layer can be everything. Can be S3, can be HDFS, can be DCS. And we mount them together. So then I think the infra engineer or maybe the machine learning engineers, they can focus on their use case. Everything is from Alluxio. But we put them all into the same namespace. There's no migration paths. It's much more easy for data copying or migration.
Very interesting stuff. Let's bring Sean Knapp back into the conversation maybe and kind of talk about this. As I think about it, and I'm always trying to map different theories, to go back to postmodernism, different theories of how to provide for data. We had data federation, data virtualization 18 years ago, I guess. Composite and Denodo came out, and there were some other folks in that space. There are some newer companies in the data virtualization space as well. And you're talking mostly about intelligent caching, for example, and just being a bit more federated in your approach. But how do these worlds come together, like dynamic data pipelines, which you talk about at Ascend, and technologies like data federation or what Bainon is talking about? How do those worlds come together in your mind, Sean?
Yeah, well, I think they absolutely do start to collide. And the reason why I think that is, we see a lot of our customers and other companies in the industry as well adopting new approaches such as data mesh, which is really fantastic for a variety of different reasons. Outside of all the marketing spiel about it, I think about this as an old former engineer, which is, how do we just get more people thinking about data as a product and a data first mindset versus a data being the byproduct of the tools we work with? And the data mesh approach generally has you thinking data first, create a data product as part of a data domain, and publishing that almost as a contract, just as you would a microservice as an API, but connecting your mesh. Now, the catch is, and we see this especially the larger the company, the more mature their stack, they also now, as Bainon highlights, they want to run data domains and data processing across clouds, literally Amazon to Google to Azure, and they're publishing a data product from one domain. For example, they have a lot of their Google ads and click data that's sitting in BigQuery, and they're doing a bunch of data processing in that domain, publishing a refined data result. Then they want to go unify that with a bunch of the stuff they have sitting in Azure, for example. And how you can even optimize the network transfer and the durability of that data so you're not hitting a lot of your costs is really, I think, quite important. And so I think if I think about this from a CIO hat perspective, a lot of this comes down to some really basic principles, which are, one, they got more people touching data than ever before. They're building more data pipelines and producing more data products than ever before. They're integrated into more tools as well, which, we get this exponential explosion of complexity. But then as a result, they're more likely to incur a lot of cost. And so how do we introduce enough advanced layers of technology, automation, caching, et cetera, really help them run as free and fast as possible, but doing so safely? Which, I mean, in many ways, and again, I know DevOps and data ops are complex terms, but for me, I always like to simplify it down. I like to call it, the recovering engineer CEO brain. DevOps was all about how do we get more people to write more software faster and safely, and data ops, despite there being a lot of other aspects to it, it really boils down to how do I get more people working with more data faster and safely. And so we see the whole world, the whole industry really converging on this. How do we get people upstack? How do we automate a lot more of the stuff underneath it? How do we get them to think data first, kind of like in DevOps, think API first, and reorient how we think about the impact of what we're building, kind of back to this whole postmodern data stack.
Yeah, let's bring Mike Ferguson back into the comment on this. At the end of the day, again, we need to focus on business value and getting things done. And it's very easy to get excited about new approaches and new ways of doing things, but it's hard to pull off. I mean, you think about, especially in lean times, it's very difficult to get some new CapEx project launched. So it's like, how do you do that? How do you counsel your clients who look at this vastly changing world around us and get them to remain focused but still be strategic? What's some advice you can give for CIOs who hear this and are just like, geez, what are we going to do? How are we going to prioritize our spend and our architectural approach to using data? What do you think, Mike?
Great question, Eric. I mean, I think, in all honesty, it has to be pinned on outcomes, business outcomes. I mean, we when you get to the C-level of any major business, that's what matters. It's how do you improve those outcomes, and so therefore, there really needs to be greater organization. If we are in a world now of more and more people doing this, democratization, upskilling people around the organization to go and do this, then we can't just have a kind of wild west of siloed stuff going on out there. There has to be a kind of coordination of all of these projects, and so I think there's a need. It's not, where it used to be in the early ETL days was centralized. And then we kind of gone up the other end of the spectrum and all went decentralized. You kind of want somewhere in the middle, which is federated. And I think that's really where, there has to be some organizational element to this, nothing to do with technology, where there is some kind of program office which is coordinating the development of data products that Sean was talking about, but that they're tied to outcomes. So if you've got a strategic business objective at a bank to reduce fraud by, 10%, by middle of next year or something, then next question is going to be, well, what data products are we building and who's building them in order to help us reduce fraud? Mm-hmm. So the whole thing's tied to that outcome. And what machine learning models are you going to build to reduce fraud? What BI reports are you going to produce to reduce fraud? So what's the collection of stuff that we're building? Who's building it? And where is it happening around the organization? And how are we going to coordinate and integrate that and deploy that in order to achieve that business goal? So the whole thing, to me, has to be tied to business objective, which is why sometimes when I see a lot of technical demos and people show me lineage diagrams and stuff like that, I get very frustrated. The lineage diagram ends at the BI report. And I say, why doesn't it end at the outcome? You know what I mean? Why doesn't it end at the outcome? So that I can pick this outcome up and say, what's hanging off of it in order to deliver on that? So to me, I think that's the ultimate hook. If you ever get lost, if you like, in a sea of all of this stuff that's going on, you kind of need to climb a ladder and look for the hook that says outcome, and says, what is it that we're doing to achieve these goals? And that's the anchor. It's business strategy alignment, I think, is the anchor here.